of otolith, which are great because they are chronometric, so you can look at the age of the fish, and they also grow in proportion to the fish, so you can back calculate the size of a fish at an earlier age. Now, another great feature of otoliths is that they take up different trace elements and stable isotopes in some proportion to their ambient availability. So if you have water chemistry from potential habitats, you can establish past habitat usage of a fish. If you have distinct signatures for different populations, you can look at stock identification. And finally, using certain markers, you can look at movements along the salinity gradient. Now, this last point is going to be the focus of my talk today. Now, before I get into the nitty-gritty of my talk, I just want to give you a quick background. Now, generally, for movements along salinity gradients, we look at strontium to calcium and barium to calcium ratios. Now, freshwater habitats overall generally are depleted in strontium to calcium and have higher barium to calcium signatures. Now, the ocean is essentially the opposite, with much higher strontium to calcium and almost negligible barium to calcium. Estuaries tend to be sort of a mixed bag. Strontium increases pretty quickly along the salinity gradient, but barium to calcium, it tends to have a very dynamic nature because of the unique hydrology of estuarine systems. So both of these in combination can be good indicators of movement through salinity gradients. So the research questions that I wanted to address with my data are there any general differences throughout the range in the size of emigration of fishes or in the habitat use between the species? Is there any relationship between the latitude of the watershed and the size of emigration of juveniles? Now, here we would think that because in southern sites, spring starts a little earlier and the summer lasts longer, that you'd have larger fish emigrating from southern rivers versus northern sites. And I also wanted to look at where the two species overlap. Are fish utilizing similar nursery habitats, or are they spatially segregating? Are emigration sizes similar, or are there any differences? And are these at all related to general watershed characteristics? So I had fish from about 20 different rivers ranging from Florida up to Maine. Now, I want to point out here that all the fish I'm referring to are adult fish. So while there could be a range of nursery habitats used and a range of emigration sizes, these are the fish that survive. So this is essentially the traits of the fish that survive to reproduce. So I embedded all of my adult otoliths in resin, and I took a transverse section, which I've indicated here with the two red lines. And this is what this looks like when you polish it down to the core. So I used laser ablation inductively coupled plasma mass spectrometry, and I looked at concentrations of calcium, strontium, and barium. Now you can see right along there's a transect here. This otolith was already shot with a laser. And I also measured the otolith perpendicular to the daily growth rings from tip to tip. Now this is important because, as I mentioned, the otolith grows in proportion to the fish, so I can estimate the actual size of a fish at previous ages. So as I mentioned, freshwater habitats are depleted in strontium to calcium and enriched in barium to calcium. So in this plot here, this is just to explain how I looked at habitat shifts. So on the x-axis is the distance from the core in microns. So essentially you should have a mirror image here because both sides should be the same chemistry pattern. And on the left-hand y-axis in blue is strontium to calcium, and the right-hand y-axis in red is barium to calcium. So in the center you have your nursery habitat signature with your low strontium and high barium, and then as the fish emigrates into estuarine systems, strontium jumps up quickly, and barium also jumps up. Now, I also did sort of the alternative here, where barium to calcium can drop, but it's important to note that in what I'm calling this estuarine signature, that barium isn't quite at the negligible marine values here. So to give you a couple of real examples, this is the chemistry from an eel life that was caught in New Hampshire. Now, this is a fish that I would say moved directly from freshwaters to the ocean. And you can see here, there's a distinct shift in barium to calcium from high to very low levels, and strontium to calcium goes from lower to higher levels. And so sort of the alternative pattern that I generally saw was a fish that used estuarine habitats. Now again, you can see there's this freshwater period with lower strontium to calcium and higher barium to calcium. And then the two signatures shift pretty simultaneously, and this is what I would call the estuarine habitat portion of the fish's life. And then finally, the barium to calcium drops while strontium to calcium stays high. So this is what I determined the fish shifted to the ocean. So, as I mentioned, because otoliths grow in proportion to the fish, I wanted to look at the actual size of the fish at emigration. So I plotted the total length of the fish against the otolith width in microns. Now, here I did separate plots for each species, but for both I looked at larval, juvenile, subadult, and adult otoliths to ensure that my relationship encompassed the entire size range that I'm observing. So, as I mentioned, I had 20 study sites. They were a little bit more densely located in the northeast, but I did have some southern sites going all the way down to Florida. Now, to look at watershed characteristics, I used the USDA watershed boundary data set at the HUC 10 level, and for the purpose of illustrative maps for my talk, I just took all my maps from Google Earth. So, to get to the results, first, are there any general differences in habitat use and emigration size between the two? So I looked for each species separately. I looked at the percentage of nursery habitat where the fish used strictly freshwater nurseries, strictly estuarine nursery habitats, or some combination of the two. Now for alewife, it's kind of striking here. You see that in the northern sites, and the sites are listed from north to south, you have a high prevalence of using only freshwater nursery habitats in northern sites. And the further south you go, the more common estuarine habitat use is. Now for blueback herring, it doesn't appear to be any sort of similar trend. But what I did notice is that blueback herring overall used strictly freshwater nursery habitats about 8% more often than alewife did. Now for using strictly estuarine nursery habitat, they were very close. For alewife it was about 26%, and you can see for blueback herring it was just under 29%. But what's interesting also is that use of a combined freshwater and estuarine nursery habitat was about 10% higher in alewives than bluebacks. So for size at emigration, there was no significant difference. This is just a histogram showing the length at emigration to sea. For all my charts, alewife are represented by red bars and blueback herring by blue bars. Although there wasn't a significant difference, alewife were a little bit larger, but the difference wasn't statistically significant. So is the size at emigration related to latitude? As I mentioned, you would expect that in southern sites fish would be larger when they emigrated from nursery areas just because they have a longer growing season down south. And you can see that this trend was indeed present, and about 34% of the variation in alewife size at emigration is related to latitude, and for blueback herring it's over 48%. So this is a pretty striking trend. And I should also point out here that these are actually the mean total length by sites, just so I didn't have, would have had 400 dots, so this is a little bit easier to visualize. And so finally, to look at sites where both species coexist, are there any trends or distinct patterns related to watersheds? So just before I start talking about these results, in the upper right-hand corners, I'm always going to have a map just to orient you to where on the coast I'm talking about. And then on the lower right-hand corner is a map just to give you an idea of the actual watershed. The upper left-hand corner is a histogram showing the distribution of the emigration sizes. And I also want to note here that all these histograms are looking at emigration to sea. I did make a note in the bottom indicating the specific habitat use for the two species. And so to get into this is my first site where both species co-occurred. This is East Machias in Maine. And there wasn't a significant difference in emigration size. Now this is a relatively small watershed, just under 1,000 square kilometers. And here both species were strictly using freshwater nursery habitats. Next is the St. Johns River, which is a little bit further south in Maine. And again, another relatively small watershed, just under 1,000 square kilometers. But what's interesting here is that alewife were statistically significant larger at emigration size. And again, both were strictly using freshwater nurseries. Now the Mystic River in Massachusetts is another site where both species strictly use fresh water. But what I want to point out here is that this is Boston Harbor right here, and so these fish are swimming straight through highly urbanized Boston, and so these two lakes up here in the corner are essentially the only good spawning and nursery habitat in the system. And here, as in East Machias, there is no statistical difference in emigration size between the two, although alewife were slightly larger at emigration. Next is the Monument River in Massachusetts. Now this is a really interesting site because while alewife did use a little bit of freshwater nursery habitat, it appears that these fish were primarily using estuary nursery areas. And it's very interesting because blueback were much larger at emigration to sea than alewife, and the difference was statistically significant. Now the next watershed is also a very interesting case because this is the Gilbert Stuart River in Rhode Island, and here this system is right off of, this is Narragansett Bay, and you have a large estuarine area in here, and then this is the freshwater head pond. Now historically it's been thought that alewives prefer ponds and slower moving spawning habitats, and blueback herring prefer faster moving habitats and spawn closer to the head of tide where the two species overlap. But here I actually saw the complete opposite. Blueback herring were strictly spawning in freshwaters and using only freshwater nurseries, and alewife were spawning and using estuarine nursery habitats only. And this is another very small watershed to less than 100 square kilometers. So next, here in New York, I looked at the Hudson River, and here you had the more traditional alewife were larger at emigration size, and both species are strictly using fresh water. Now the Hudson River is a huge watershed, and blueback herring even go up into the Mohawk. So you would expect that there's more than enough nursery area that estuaries aren't needed. So next is the Nanticoke River in Delaware. Again, this is an interesting site where both species are strictly using estuarine nursery habitats. And blueback herring were larger at emigration, although the difference wasn't quite significant. And then finally is the Chowan River in North Carolina. Now this is a really interesting site to me because, again, alewife were significantly larger at emigration, but both species use a combination of freshwater and estuary nursery habitats. And what's striking is that when the two species emigrate from freshwater, there was no difference in size. So it appears that as soon as the fish reach some minimum size threshold, they're emigrating freshwater habitats and utilizing more productive estuarine habitats, most likely here in Albemarle Sound. So just to wrap things up, were there differences in emigration size? No, not statistically, but alewife were slightly larger in a lot of the cases. And what's interesting is that alewives were using estuarine habitats quite more than blueback herring, and more blueback herring were using strictly freshwater nurseries. Latitude is highly correlated to emigration size in both species. There are likely other factors influencing that. And in rivers where both species occur, it's likely that there is some sort of relationship to habitat availability, but obviously more analysis is needed than what I'm showing here. So to go more into detail for other watershed characteristics I'm looking at, I'm actually using multiple regression to look at the effects of latitude, watershed area, accessible river kilometers, and also the amount of urban area within a watershed to model size at emigration to see if there's some way that you can predict the size that fish are going to be emigrating. And more important for management purposes, I'm trying to look at if there's a relationship between watershed area and available estuarine habitat and habitat use and emigration size where the two species overlap. And this is important because where we're trying to restore these populations in many of their native rivers, it could be important where in some sites you might think dam removal is the best strategy for restoring nursery habitat, but if there's a large estuary, maybe money is better spent restoring estuarine habitats and ensuring water quality is good in nursery areas. So with that, I'd like to thank my advisor, collaborators, and pretty much every state and federal agency and a couple of university labs along the East Coast that have river herring sampling programs and got me fish.